Hi, I'm Mike Dopsa, and this is the magic of modern XR. This talk was originally given for Steve Mann's Superhumachines course at the University of Toronto in 2025. What you'll see in this video is full field slides like you're seeing now, intercut with video from the original presentation. The link to download these slides, any prerequisite readings, and the course website will be available in the description. All right, so let's jump right in. What is XR as defined by these readings? Well, first and foremost, XR is technology. And specifically, it's technology that understands the environment around it. What's it mean to understand the environment around it, right? Because it's going to be using sensors and a computer and some software. And so it has an understanding of space and time and sound and light in a really similar way to you and I, and the way we look around us and observe where things are. We keep track of the things that we've seen, and we know that those things are there. And as we move around, we understand that we're moving through space. We can see those things moving around us, and we can reach out and touch them because we know where they are. Similarly, XR technology understands the world. It observes using its sensors. It maps using its software and its algorithms, and recalls and remembers using its memory and storage. And so by having a piece of technology that can understand what's around it in the same kinds of ways that we do, you've got a technology that can understand reality and can understand life experience and demonstrate that back to us. It's technology that enables you to access the computer's understanding of reality. And it translates that into a medium or into a way of understanding that we work with. It's almost like a wrapper for computers and people, right? So it has a mathematical map of the world, but it shows you in your eyes something on the ground. You know inherently, immediately, how far away that thing is. You know inherently, immediately, how big something is. And that's because the computer has done the work to present information to you in a way that you're naturally ready to receive. That's the key that we're going to keep coming back to here. It is inherently computer. It sees things the way you do, and it talks to you in your language, you being a person, a human. And you can think about that as a cyborg, right? Who remembers reading about the cyborgs from the readings? And this is an interesting question because you can go all the way back to paddleboarding. You can go to a non-electrical piece of technology that could make you a cyborg, like a bicycle, right? But what we're going to talk about today primarily is virtual XR and technologies that enable you to be a cyborg and recognize virtual data. And so that comes from computing, from electronics, and that's why there's so much overlap with robotics. Because it's basically your robot eyes, your robot ears, and it's also your friend that demonstrates things to you in person. Okay, so that causes a little bit of a question. It's like, what is the boundary then of XR? Right? Where does XR end and begin if almost every form of technology is XR, right? And I believe the boundary to XR is theoretical. And in practice, we're only really prevented from engaging with something as a piece of XR if that technology doesn't exist yet. So in theory, I can imagine a system where I think something, I do nothing other than think, and a drone brings me McDonald's, right? Everyone can imagine that system. That's XR, right? But we can't necessarily build that immediately today. Or if we could, it would take some development. It's not here this second. So that's kind of where the limit is when it comes to XR. The boundary is just what exists right now. And we can think far beyond the technology of our time. As we know, these papers come from, well before there were iPhones. And the information in those papers is equally relevant now, if not more relevant now, in the time of smartphones and AI and the internet, pervasive in every part of our lives. So we can think well beyond what we have today, but if we're going to put time, effort, money, etc., energy into building something for XR, for people, for today, or for the next little while, it's a helpful exercise to understand where we're at, what the practical boundary of all of this stuff is, where the technology has its capabilities and what it's really good at, but also where we aren't yet. We heard a couple of minutes ago, some people found that there are things that aren't developed yet, and that's the first thing that they want to build. I think that's a great idea, because as we begin to fill out this infinity that is XR, we can kind of start to spot all the holes that are ready to be filled or where the innovations are needed. So keep that in mind as we continue through today. All right, so, perfect. Who remembers this graph here? Yes? You all seen this? All right, perfect. So we're going to go through the 6 different colors and talk about this. So first is virtuality, right? We got this one right here. Green, cyber, bits. And so if we're thinking about XR technologies, XR devices, the virtuality construct and that dimension tells us something very, very, very important that we're always going to come back to, both in this talk and also throughout XR. It's a computer, right? It's a computer. All of these devices are computers. They do computer things. They have all of the capabilities you would expect a computer to have, right? They process data. They calculate math. They run apps. Those apps are made by developers. So it's just like it would be for a PC or a phone. An XR device is a computer that runs an app that is buildable by someone like yourself. It's written in code. It's not any different than the computer code that would be written for a smartphone. Well, what it's doing might be slightly different, but foundationally, fundamentally, it's just code written in the same languages, using the same kinds of methods, and bound by the same kinds of limitations. If you have a phone with a tiny little battery, what's going to happen? It's going to have bad battery life. It's going to have low battery life. XR devices are no different because they're computers. So everything you know about computers, you don't have to forget. You can hold on to that. That's a huge portion of what makes XR in the virtual space XR. The other thing it can do is it supports the web. Why? Because it's a computer, right? It's a computer. So you can connect to other computers using the web. You can connect to APIs that extend the capabilities of the computer itself beyond what it can do on its own because it's a computer, right? Anyone not clear about how much of a computer it is? Awesome, perfect. So now we move on to physical reality. So as a computer, what does this computer do that sets it apart from just being a computer? Well, one of the things, and we've touched on this very briefly, is it has an understanding of the world around it and the environment. So that's more than just having a GPS location. That's more than just a singular position. It knows its movement throughout space. It knows where it comes from. It knows where it's been. And it has a memorized map of these things that it uses simultaneously to remember where it is, just like we do. We walk into a space, we remember where the door was when we came in. We visit a room for the first time, we remember roughly how the chairs were arranged because we were there. We have a memory of it. We saw it, we experienced it, we used our brain and our eyes and our senses to figure out where everything was. So it does it a little differently than we do, but it understands the environment in a similar way to us. The other thing that it's similar to, and I already mentioned this, so I'll go quick, is robotics and self-driving cars. If you combine these first two, virtuality and physical reality, you could consider the IoT, of course, digital twin, but also robotics is deep within drones recognizing where they're going, cars trying not to run into people, etc. Okay. But the final pillar is us, sociality. And so these computers, these robotics type computers, have a specialty that defines them as XR devices, and that it understands us. So just like it understands how its own movement works, it understands our movements. This could be, in many, many cases, from a wearable. So as we move our heads with a virtual reality headset or glasses, it knows which way we're pointed. It can understand the angle that our bodies are at. It's using sensors to detect our hands, to detect our eyes, our faces, using microphones to detect our mouths. And as mentioned before, there's various types of visual displays that are designed perfectly to work with our two eyes. That gives us depth perception. That gives us spatial awareness. Yes?
So I was wondering, on your point, is there any interest in recreating the human field of view? You know, where in the periphery it's more blurred out than the central field of vision?
Great question. So just asking about if there's interest for XR devices to replicate or recreate the human field of view and other parts of vision. And the short answer is yes, absolutely. So based on practical physical limitations of engineering and innovation, it's harder to have a large image that looks really good. There's more that has to be done, more pixels, more energy, more light, better optics, all those sorts of things. So that's why we start with the smaller field of view and are slowly getting bigger and bigger and bigger. There's also other sorts of trade-offs that we don't have to get too deep into, but basically bigger is generally harder. But what we're seeing now on the most recent devices and I think this is the perfect segue from what you're talking about, is something called foveated rendering, where it quite literally only renders what you're looking at high quality. Everything else is blurry. Because I don't know if you realize this or not, but if you stick out your thumb as far away from your eyes as you can, and you look at your fingernail, let's all do this. That fingernail, that amount of space that takes up the top of your thumb, that's all you ever see in focus. That's it. You think you're looking around the whole room and you're seeing everything is in focus, but at any one time, your eyes are only getting that little tiny 1% of vision. Don't look too hard, you might drive yourself nuts. You can't unsee it after everything's blurry, right? But what the headsets are doing now is to be more efficient and to be more human-like. They're actually taking that into account and not only spending rendering time on just that one portion, but they're also basically able to detect better what you're looking at, where you're going.
Efficient too, right?
Much more efficient as well. Absolutely. Yeah. So and that's a perfect example of how it is a human-specific technology. Because if it were purely robotics, you wouldn't want part of the image to be blurry. You would want to get as big field of view as possible, as high resolution as possible, capture everything, analyze every pixel. But when it's specifically designed to be viewed by a person in a natural way, you want it to match as close as possible. And so that's a really, really wonderful example. Right? It's designed to stimulate our senses. Right? We've got screens for our eyes, speakers for our ears, haptics for our touch and our hands. It's shocking how much haptics improve your immersion and improve your brain's understanding of what space it's in. If you go to touch something and you don't feel anything versus you go to touch something and you feel something but it's wrong, it's still better to feel something even if it's wrong. Like, dramatically better. Your brain will feel like it's in that space much more. The two senses that are mostly untapped at the moment is scent and taste. They exist. I welcome any of you to create an XR device that specializes in scent and taste. I'm not sure if anyone is interested in that, but that's certainly a hole in the XR technology space at this point, and I welcome everyone to try. That would be a lot of fun. Good smells, hopefully. Right? Yes?
Wouldn't the, I don't know what they call them, the 4D or 7D experiences in cinemas, include the smell thing?
Yeah, they exist. They definitely exist.
But not within the glass headset, you mean?
Not as in an all-in-one system, wearable, exactly. Usually, I think from my understanding of scent technologies, they're really big systems that kind of mist.
Yeah.
So they have to have the mister, they have to have all the different kind of perfumes, and it's almost like pixels in displays where you have a red, a green, and a blue. Right? That's not white. That's a red, a green, and a blue hitting the same spot at the same time. It's additive, all three of them. They do that with scent, where they take like a little bit of this perfume and a little bit of this perfume and a little bit of this one, and you can concoct some sort of a mediated smell among that spectrum. Sounds crazy, it is a little crazy, but that's how it's done right now. So I imagine in the future, if we are to get perfect scent or perfect replication of that kind of system, it'll probably be a much higher quality, more efficient version that can reproduce more scents than can be reproduced now at a more granular way. Maybe the scent's coming from over here, that's specific. Maybe it's coming from over here, right? So, yes?
In theory, wouldn't scent in the future be like BCI that just stimulates our olfactory nerves in the exact way that the scent would?
Okay, so that's also a great point. What about BCI, right? What about brain-computer interface technology that is directly pumped right into your brain? And I'm not talking about just reading the signals that are coming out of your brain, I'm talking about writing directly to your visual cortex, writing directly to your sensory nodules. It is theoretically possible, yes.
Well, then you could
And-
have truly immersive technology that would make me feel like I'm going for a swim, and you'd actually feel like you're getting wet in the lake.
Absolutely, yes.
You could go for a virtual swim if you had that.
Also very, very theoretically possible. In today's world, writing to the brain is something that hasn't, I wouldn't call it figured out, hasn't been completely discovered yet. Reading from the brain is getting really, really, really good, right? And it's things like the Muse Athena. There's other larger sensors that you can get in labs that do very meticulous understandings of different electrical signals. There's Neuralink, which I'm sure people have seen, that's inside your brain reading all the signals. So that's one half. The other half is writing to your brain, which is basically creating something in a computer and putting it directly into your mind. We're not quite there yet, and personally I would say I'll wait, for version 2 or version 3 maybe of right-to-brain interfaces. But that is where all of this is going. If you wanted to create a perfect version of the technology that does all of the things that makes you feel all of the possible things to feel, it would be a right-to-brain system. So look out for that in the next 30 to 40 years, I would say. And also an untapped place for innovation. If someone's interested in writing directly to the brain and feeding information in that way, I would just say be careful, because we don't know yet. And it's electrical signals in your brain, so just yes.
There's actually something called DBS, direct transcranial stimulation, where
Yeah.
they implant electrodes and it stimulates like different regions of your brain, and it's used currently for Parkinson's. It's not fully made legal here to
Yeah.
do it to have it outside of the clinic, but it
Right.
is in America.
Very interesting.
Yeah.
So she's mentioning a right-to-brain precursor technology that is being used for Parkinson's that can affect your brain chemistry and actually change what's happening in your brain, I imagine from some computer or some electrical impulses. So yes.
I could talk a little bit more about that if you
Yeah.
want, but it's basically just it prevents beta oscillations, and it's an inhibitor for the SDN, which is the subthalamic nucleus. And then on top of that, in 1970s, there was a bunch of electrical engineers who decided I want to make implants for the brain because they were interested in that. So they decided to do cochlear implants and retinal implants. So cochlear implants have already been done. That's a commercial product. Retinal implants, whoever picked retinal implants in that electrical engineers are still working on it. Currently, it's getting close. I believe they just came out with a commercial product that's 50% of your visual field right now. But yeah, just wanted to.
No, amazing. Yeah.
Ask us about mind mesh as well, too.
Yeah.
If people are interested in working on that project.
Wonderful. So if we've got a lot of right-to-brain or read-brain interest in this class, then we're in good shape. We can take some of the things from this lecture and think, how about we do a brain version of that? And you're on the right track for innovation. So that sounds awesome.
XR mind mesh is read-write at the same time with a crossbar switch. That'd be a lot of fun, too.
Amazing. All right. So I'm going to hit us with a couple of quick demos. And these are going to be visual demonstrations of some of the things that we just talked about within the context of what we can do today. And again, we're specifically looking at things that you can build today, download a piece of software from the internet and start writing code, purchase a product from the store and bring it home today. Some far future brain BCI stuff, we're not getting super deep into that today. I don't have a demo of BCI tech today, but we're gonna take it from an XR device perspective, and we have just a moment. I'm going to switch us over to that now.
All right, so now I've got the Apple Vision Pro on,
and I'm going to cast my view so that you can see what I can see. And I can see an infinite number of the screen. Okay. So the first thing that I want to talk about and show, that's next, is I want to just show you that this is a computer. I am wearing a computer. And we can think about it in the same way that we think about our phone or an iPad. It's got a CPU, it's got a GPU, it's got all that, but it's also something I can just go ahead and touch with my hand. It's like a giant iMac or some like a huge screen that I can basically interact with, but all the same ways that you imagine I could go to Wi-Fi on my phone and look up what's around, I can do that here. And so, by being a computer, you could expect that I have as many screens as I want. I could have settings, I could have apps, I could have browsers, and that's all being shown to you in a way that you understand, and the way that we understand is big screens. Because the device has environmental understanding, it's keeping track of where I'm looking and where I am in the room. So if I decide to, I can just walk away and turn around. And what you'll see is the virtual screen stays put. It stays exactly where I left it, just like you'd expect from a real TV or a real computer monitor, any object that's in the real world with you. And the reason it can do that is because the device has an understanding of where it is. It knows where the room around it is, it knows the way that it's rotating and the way that it's moving, and it remembers where it's placed things in relation to itself. So over time, as I go around to the back, as I look around each of the angles like I would on any other TV, it works exactly as expected. The only way that it can accomplish that is by having a confident understanding of what's around it. But it's not limited to just understanding the environment. Of course, it can also understand people and myself. And so a great example of how that works is using the personas. So this is me speaking in real time, and I'm wearing the headset. So this is not a video. This is not a mirror, a real one at least. This is a fully virtual representation of myself. And if I'm moving my eyes or blinking or moving my lips, it's using the cameras and the sensors on the Vision Pro itself to capture and re-display that back on a 3D model, a fully virtual 3D model. What we're looking at here is 100% virtual. And the only way that it can do this is if it has the software, the hardware, and the synchronicity between them to know what my face looks like, to know how my face is moving, and to replicate that in a way that looks right to me and to other people. So if I were on a Zoom call or a FaceTime where everyone is an avatar or is a persona, we would all be able to look at each other and recognize each other and interact the same way we would be interacting in person. But it's 100% digital. So that's one of the things that XR can provide. And
you can tell that, it's not full body. I only have shoulders here. And my hands are being captured using motion tracking as well. These aren't my real hands. They're very well aligned to how my real hands move, but they are not my real hands. And anytime it's not 100% sure, or if it's feeling inconfident in one of the pieces of information it's delivering, it has a graceful sort of fallback. So if I bring the microphone really close, you can see it blurs out my mouth. And that's mostly because part of the information that it's using to record my mouth is now gone. So it's choosing a way to fill in the gaps and deliver the right information with its limited understanding.
It's not removing the mic. It's not tracking the mic. It's only tracking my hands and putting them back. So if you imagine compositing, it's like stickering in my hands. It just happens to have them in the perfect spot because it knows where it is, and it knows where I am in relation to it. Isn't that crazy?
But yeah, if you put the mic right up to your lips,
It has no idea. It just sees that it's covered by something.
it just makes your lips blurry when the mic is up against
Exactly.
your lips.
Yeah.
Because it can't get that information.
It doesn't know, and instead of guessing, it doesn't show. XR is larger than the subset of all things you can experience as a natural person. That means it can do all of them and more. We'll come back to that. So, the last thing that I want to show is an interesting example of diminished reality. And this, again, requires several of the components that we already spoke about, the environmental tracking. This includes spatial audio. This also includes diminished reality. So not only am I going to add onto the world, like I've done throughout the rest of this demonstration, I'm going to subtract from the world while adding to it. And you'll see what I mean in a second. So here I go with, whoa. So I have perfect sunglasses that has completely blacked out my vision. Can I give you this microphone here, just so I don't feedback? Thank you. I'm going to come this way. And let's go over here. So as I make sound, I can visualize the sound reverberating off of the environment around me. It knows where the environment is because it's made a scan. It's regularly scanning. It knows where I am in the environment because it's tracking. And it's reduced or diminished the natural environment that I'm expecting to see and is overlaying it with something completely new. But it's still here. It's not completely virtual. This is still this table. I can touch it. I know it's here. I can see things that I could have never seen before. And I'm also blindfolded and diminished in a way that I wasn't before. So, I always think it was an interesting way to think about diminishing reality. It's not just about covering it up. It's not just about using something else. It's about the ability to do both at the same time. Awesome. All right. So, within XR, you can add things into your real space. You can take things out of your space. You can completely
virtualize your environment and exist entirely in virtuality, or you can have complete base reality. What's important to understand is XR is somewhere in between all of these things. It's a little bit or none of it of any of the three, of physicality, humanity, and virtuality. And so it's hard to think about a hard boundary for where XR starts and stops because of the vastness of what you can fit within it and how far out it extends.
You can go to 0, which is none of any of them, none of the natural, none of the human, none of the physical. And in any of those three directions, you can go as far as you want. Right? And so if you imagine it's normalized to like a 0 and a 1. Well, 1 is like as much as possible, you can't get any further, it's like infinity, right? You could be anywhere between 0 and 1 on the X, the Y, or the Z. You could be totally virtual and not at all real and 100% human. You can be anywhere within that 3D space as well. So I actually see it not as a boundary, but as a seamless spectrum in all three ways, all at the same time. And you can through that, you can derive R, or reality. You just turn the virtual one totally off, that's reality right there. There's your plane of reality. You take away all the virtual, right? You could also, in a single direction, just say, okay, well, here's just virtuality, or digital computers without all that other stuff, and it's just 1, 0, 0. You can imagine reducing any of them as much as they go, all the way down to nothing. And kind of the point is that you have the ability to infinitely move between them at any time, and then also choose to specifically lock one at 1 or lock one at 0 if you want to for whatever purpose. All right, so I hope you had some good ruminating time, some good time to think about what we've gone over so far. And if you haven't noticed, the slides have been color-coded to match the 3 vector directions. And now we're going to do the other 3 colors, which is a combination of at least 2 of them. I must admit, the yellow one should be white because it's all 3 of them, but we're going to pretend that it's just the yellow. Okay, so the other thing we're going to be focusing on for this portion is specifically things available today. And what I mean by that is, like what I said earlier, you can grab an existing computer, start writing code, grab something from Amazon or from a store, and buy it today and start working on it immediately. So we're gonna stay within the realm of now, and we can project our thoughts into the future for how we will create improved versions of this in the future. But again, it will be we'll be starting with the now. All right. So our first look is at bits and atoms. And we're thinking about XR devices in general that are combining our bits and atoms because, well, that's what the devices are. They are a combination of the virtual and also a physical operating computer. It's electrons, it's software, it's hardware. That's what this whole section and category is. So, believe it or not, all the things that I described about an XR device being, a phone already is. A phone has the ability to track itself in 3D space. It has the ability to take photos. It's a computer. It works the way you work in terms of it can show you images to your eyes. It can show you, it can create sounds for your ears, all those sorts of things. Now, it's not a wearable, it's more like a holdable, right? But it is, in and of itself, capable from a technical robotics style perspective capable of producing XR experiences and mediating reality similarly, almost identically, to the ways that other devices do. The next one is VR and MR glasses. So that's very much like what I was wearing a moment ago. And here's another example. This is a Quest 3. We've got a Pico over here as well as the Apple Vision Pro. 3 of the premier modern headsets that have these capabilities. And why do I say VR and MR and not AR? So very quickly, what you're looking at when you put on one of these devices are 2 phone screens. One phone screen goes to your left eye, the other phone screen goes to your right eye, and in between, you've got a lens. And that lens is basically what makes those screens visible to your eye at this distance. And the combination of those, it's called the stereoscope, but basically the combination of that is like digital virtual binoculars that you can wear on your head. Right? And so this is one type of display that you'll find in XR devices, wearable XR devices today. One of the main things to note about it is that for viewing the world around us, it's using cameras. So normally you don't use cameras to view the world, you just use your eyes. But as some of you remember from the readings and Steve's presentations, you can use cameras and look through those as well. Eyes and cameras work very, very, very much alike. Sometimes they do exactly the same things. And what we have here is basically a sandwich with cameras on the outside and a phone screen for each eye on the inside. And that's what lets us pass through, that's what it's called, pass through the light from the world into our eyes. It goes through the computer, back out through the screen, boom. So that's one of the ways that you can do it. And that's the way that a majority of the headsets today are working. So the other option is what you normally find in AR glasses. So I'm going to kind of denote those MR VR goggles versus glasses. But really, oh, this is perfect. We got a projector here. Really, the difference is that these screens, there's still 2 screens, there's still cameras on them, there's still computer in them, there's still all those same sort of things, bless you. The difference is that light actually passes through the front of this and gets into your eye the same way that it normally would. So you could call these sunglasses, right? Because they are. They are this is making sound. They are glasses that bring the light from the world around you through them and into your eye. So yes, it makes things a little darker. You can see how it kind of darkens this piece right here. But importantly, when you wear it, you're still looking at the world and everything around you with your natural eyes, just with a little bit of darkening in between. And what's the second thing that they have? Is they have something called a waveguide. So a waveguide is a type of miniaturized display that uses a projector, very, very, very much like this one, I'm not kidding. And it filters through lenses that then reflect into your eyes. There's 2 of them, one for each eye, just like the stereoscope does, except instead of a phone screen blocking your eye and replacing it with a camera image, it's a purely additive system that combines, using a combiner, the light coming from the outside natural world with the virtual mediated light coming from the computer. So there's just multiple different ways of doing the same thing. Also, like we were talking with the BCI, in the future, there's multiple different ways of doing what we're doing now. Some of them are better, some of them are worse. Some will stick around as backup for when people don't want surgeries, and some of them will be replaced by better innovations. And that's just where we're at. It's in the middle of all of this. We haven't found the be-all, end-all, one-size-fits-all, and it might be a really long time, or we may never. We may always want different displays and different systems for different things. People still use desktop PCs and phones in the same year. It's not like one replaced the other, they're just 4 different things. So these are pretty cool. You can come check them out later if you want. It doesn't do a whole lot, unfortunately the software is very old, but the screens are cool. And this is a peek into what the AI smart glasses of the future are going to be. Don't believe the new Meta displays. They only have one in the right. There's not both. To get real augmented reality, you need both. And them working together, because we have 2 eyes, so we need 2 screens. Okay. I'm gonna go a little quicker here. Okay. Put this down real quick. So, quickly, foundationally, as a part of being an XR device, it's a computer. Coming back to that, okay? It has CPU, it has a GPU, it's got RAM, right? It's got radios, Wi-Fi, Bluetooth, all those sort of antennas you'd expect, and power. Battery of some kind, USB-C to charge it. It's straight up a computer. I don't know how else to say it. If you don't believe me yet, it's a computer. It has all the same sort of things. They're miniaturized and they're tiny. And they're not quite as powerful as something that would be, EA big or a laptop, but they're on their way. The Vision Pro has a better CPU than my laptop does. It's an M2, it's an M1. It's better. And it's tiny and on my face. So we're getting there. The other thing that they have is an IMU and a gyroscope. So that's very much like how your phone knows what angle of video you're watching TikTok on, or whatever, but it's super duper duper precise, and when in combination with all the different types of sensors, you get a really accurate sense of your position, your rotation, at kilohertz rate. Really, 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 really fast. And next, we've got cameras. Cameras for computer vision and tracking, in addition to pass-through. So these are like robotics cameras. You'll see these black circles all around the device, and a specific array, typically looking towards the ground and forwards in front of you. So this has 4 tracking cameras on it, 2 on this side and then 2 on the front. And then it also has 2 more cameras just for your eyes to see color. The Vision Pro has, I believe, 12 cameras. And these are a suite of cameras working simultaneously, basically to keep itself in check, to know how far away it has moved from the last time it checked. And it's using something called SLAM. Anyone familiar with SLAM from robotics? Yes, one? Hell yeah, let's go. Simultaneous localization and mapping. Yeah. So it's exactly what a self-driving car or a drone or robotics would use to understand where it's gone minute to minute, microsecond to microsecond. And cameras are one of the most important things for doing that. And the last one I have a little bit of an asterisk on, because not every XR device is going to have this. In fact, a lot of phones don't have this, and they can still, produce XR experiences. But having an infrared laser scanner, a LiDAR, or some other type of dedicated depth sensor is really, really powerful. So what we saw a minute ago with the meshing of the room when I was clapping my hands, and we saw the Vision Pro had an understanding of that, that all comes from one of the 2 LiDAR sensors on the device. It quite literally shoots a laser at the room, mathematically measures the room's distance from it, and creates that map over time. Not everything is going to be able to do that, but most of them can. The Quest 3 is one of them that has a laser sensor right in the center. Some of them use infrared passive cameras, some of them use other methods to do it, but fundamentally, they can all understand what's around them, some just a little bit more precise. Okay, so we already talked about this. The Quest, the Pico. The Pico is ByteDance's version of the Oculus Quest for the Meta Quest. ByteDance, you may know from TikTok fame. Seems like all the social media companies are the ones that are making the headsets. It's interesting. It's Facebook, it's TikTok, and it's Snapchat that have the three leading devices. Just something to think about. Just something to think about.
Well, that's XR. It's got the social dimension for sure. It's not just bits and atoms.
That's right. Foundationally important. Then the next type of screens, we've already talked about these, are see-through displays, potentially with waveguides, potentially with something called bird bath optics that uses reflection. Things like the Meta 2, HoloLens, Snap Spectacles, Magic Leap, those all use this. And those are typically used in circumstances where it's critical for your eyes to be on 100% of the time, and there not to be any chance that anything can go wrong that blinds you. For example, if you're doing surgery, it would really suck if the camera just turned off in the middle of surgery. You know, it's good to have a fallback for if the tech doesn't work, I'm still looking with my eyes and I'm no longer in an unsafe way. I know you've had an experience where the device just decided to turn itself off in the wrong time. And that can happen when your eye is completely covered by a phone screen. If it turns off, it's off. You're blindfolded.
Well, like in the ball, it's good if you can run and carry the thing in one hand. Well, that happened to you too.
Yeah, it happened to you as well. Yeah,
it went blind, and you're basically wearing a blindfold, so you had to take it off and carry it, and then running with one hand carrying the device, trying to balance in that ball and run back with just one hand. That was good. You know, you see that on the YouTube video when the thing went black.
So moving on to bits and humanity. I'm thinking about this from the perspective of user experience, person going through a thing that's happening to them in reality. And the key part of that is the software, the application that you're actually using, the thing that you're experiencing, like clapping and seeing the colors or looking at the avatar in front of me. A lot of these experiences are built with video game engines. Honestly, that's the truth. Why? Because a video game engine is a computerized 3D world that runs in real time on whatever you want it to run on, any type of computer. It's designed for a person to use to experience a space. Sound familiar? Because it's exactly what XR experiences are. You don't always have to get points. You don't always have to accomplish some sort of video game-based design goal. But the tech underneath it, putting a person in the room, making animations, doing modeling, all that stuff foundationally is the same as you would get in game design. The other things you can use is native tools. On Apple, that's ARKit. On Google, it's AR Core. And in the future, Android XR. Those are basically ways of creating apps through like Android Studio or Xcode, the same way that you would with an iPhone or an Android app, except it's a 3D space. And lastly, web. Web is also one of the premier platforms for XR experiences. Let's go. There we go. And there's several different options depending on your preferred flavor. If you like working right in JS, you can use Three.js, you can use A-Frame. If you like engines, you can use PlayCanvas, which is completely open source, designed and operated by Snap, but completely open source. And there's also premium private options like Eighth Wall, which do really cool things. That's coming from the company Niantic, who you may know from Pokemon Go. And they have world models. So you can go a place in the world, point your device, look at something, and it recognizes it automatically. So you gotta pay for it, but that's one of the things that's available, and that's all through web. Okay. So when you combine all of these things together, and again, it probably shouldn't be yellow, this should probably be this one here as the full spectrum of XR.
Yeah, white background.
Yeah. But when you combine atoms and bits and humanity, you get the human-computer feedback loop that XR enables, provides, and expects. So as you do something, by the nature of moving around, the computer changes. Why? Because you've moved it. It's attached to you. It has to use SLAM, its cameras, its sensors, its world mapping to know where you've gone. Because you've moved. It has to match you. It's designed for you, and you're working symbiotic. Right? If you start pedaling on a bike, you hope the bike goes. Right? It's going to match what you're doing because it's designed to, and you're a part of it. That enables using computers for things that you can only use computers for. And that's the magic of XR, is with all three of these capabilities, there are experiences you can have that you can't have any other way. And you can think about that and extrapolate from that in all directions. But, you know, XR can make you feel like you're about to jump off of a bridge. It can make you feel like you're speaking to someone in the room. It can make you feel like you're in a float tank or in some kind of magical realm. You know, all of those things are not necessarily, with the exception of the float tank, all of those things are not necessarily possible without the combined symbiosis of the computer and the technology and the reality. So you can teleport around the world. You could shrink yourself or grow yourself to an impossible scale. Something you can imagine in healthcare, shrinking yourself down to the size of a molecule to observe it and understand it and watch the way that it functions at its size. Doesn't matter what camera you have, you can't Honey, I Shrunk the Kids yourself into someone's body without using some kind of a system like this. Or growing to the size of a mountain to see where the light falls. It's just something that you can magically do using XR that you would have a really hard time doing without it, or maybe you couldn't do it all. And the last thing, which we talked about a little bit earlier with the ball game, is that the computer, the game, the software, the experience can encourage things to happen in the physical environment. So that's coming from the computer saying, hey, move over there. You actually move. That computer has now made something happen in the real world. Right? It's no longer purely a virtual system because it's interacting with something that's real, physical, that's answering to it, that's responding to it. So it combines, with the combination of that, you can induce or encourage physical movement, something like rehabilitation, fitness, gaming, entertainment, skills, all these types of things that you can't imagine just downloading into your brain like Neo from the Matrix. But you can imagine learning from YouTube, or learning from a lecturer, or learning from some kind of demonstration. And if you combine all three of those with a XR device, the device can puppet you through that. The device can teach you the steps. And that's the combination of the experience and the technology and something that understands you in the way that you work. Okay. So, very quickly have gone over the foundational capabilities of these kinds of devices. The types of things that they can do at a practical level the types of things you can do today with them. And I want you all to think conceptually. So we're going to have a little group time, and we're going to, as a group, come up with a single concept, just for this class. Don't have to worry so much about it being the perfect thing forever, okay? But you want to come up with a concept that takes one or more of these available capabilities, features, technologies, sensors, devices of XR that we were talking about today, and come up with something that makes the world a better place using one of those things, right? And I really encourage you, I'm not demanding, but I am demanding. You come up with something that is a non-traditional use of the technology. What I mean by that is, let's think beyond typing to a chatbot. Let's think beyond playing a video game. Let's think about what these sensors, capabilities, fundamental properties allow. And if theoretically it worked perfectly every time, we could do this with it. We could do something interesting. We could, I'll leave that part to you. And so, if you have any questions, if you have any thoughts or curiosities, is this, relevant? Is this not? Then please feel free to ask. Talk to us, and we're going to have a little quick. Let's see. Do we have 25? We have maybe 10 minutes. Yeah, instead of 25, let's say 10 minutes. And each group will just, maybe not a 2-minute presentation, but each group will roughly talk about what they discussed, what they came up with, and bonus, if it's related to the types of things that you're already interested in as a group. If it's related to some of the 3 topics you're going to think about for next week, or if it's related to your individual specialties, let us know. That sounds like a great start and a great approach. And if we run long, then we may have some ball fun in the hallways, and give everyone a chance to check out the headsets or the ball game. All right, any questions? Any thoughts?